These are dragon wings. And I found this particular shape, which I'm calling dragon wings, because that's what it looks like, right? Looks like the wings of a dragon. And I found it through geometry. So it's actually derived from geometry. And if you're interested and you want to know how I got this shape of dragon wings, stick around till the end. And I've got a bunch of stuff to go through here. Some of the stuff is stuff that I did back in 2017, and unfortunately, I had uploaded all of my work, like close to 3 years' work, onto Google Plus back around 2017, and then Google Plus disappeared, and unfortunately, I did not, I wasn't able to save that work. Like I have it in my notebooks, but the actual stuff that I uploaded onto Google Plus, I've lost. So, and then recently I went and I went back and started to go over some stuff that I did before, and I ended up finding some new stuff. So this video is partially about new geometrical designs. I have found new geometrical patterns and new geometrical designs, if you will. And before I start this, I just wanted to say that in the days of classical or ancient Greece, where things such as maths, geometry, sciences, arts, etc. These things were actually considered to be divine. They were held in a very respectable place, and that's why I call it, that they thought of these things as divine. Whereas today we kind of in this age of modernity and so forth, we've kind of lost touch with thinking of these things in that way, where we don't think of these things as something divine anymore. Much of the arts today, excuse me, it has very little to do with like something divine or nature, and so forth. All the kind of the things that are taught today, they're taught in a different way. They're taught in a different context. So all knowledge, like irrespective of what kind of knowledge it is or it was, in my opinion, the ancient Greeks held these things in very high regards, because in my opinion, I think that they thought of them as being divine. Okay, so now I've said what I had to say. This is just a little basic intro here. Some of this stuff is already kind of known, but I just thought it'd be a nice little kind of introduction into what I'm doing here. So what I've done is I have an equilateral triangle. I have a equilateral the square, which is what a square is. And these are equal perimeters, okay? They're 3, 3, 3, 3. It has a perimeter of 12. The triangle, these are 4, 4, 4. And that has a perimeter of 12. So these are equal perimeters. And equal perimeters do not give you equal areas, okay? So that's something different. But what's interesting here is now a triangle, it you know, how many units can it be divided into? You know, in a for a basic understanding, a triangle can be divided into 4. Okay, at its minimum. And then it goes from 4 to 9 to 16, etc. So this one, for the sake of this presentation, I formatted these so that they had 9 units each. That's 9. 3 times 3 gives you 9 in the square. You know, and you can, like I was just saying, and this works the same way. 4, 9, 16. If you were to just have the square that way, you would get 4 quarters, right? So that's your 4. So they work on the same ratio, which is very interesting, right? Because this is a triangle and that's a square. But when you're looking at units of when you divide a triangle into units and when you divide a square into units, they both have a minimum of 4, right? Which is very interesting. And so the next one goes, 4, and then it would go 9, then it would go 16, and etc. So I just wanted to point that out, that they have an interesting relationship that way, even though they're completely different shapes, really. Oh, I think I've got this slightly out of order here. Let me see if I can get this up. Where is it? There it is. Okay. And I just out of curiosity, I did the same thing for an octagon. I wanted to see how many basic units can an octagon be divided into. And what I found is that an octagon has 6 a minimum of 6 units. And the units, of course, they're all equal to each other, right? Every one of these, they're equal to each other within the square. Every one of these are equal to each other within the triangle. So the same principle applies to this octagon, where this square is equal to this rhombus, right? Because all 4 sides are of the same length. And in that way, we get 6 basic units that make up an octagon. So that's another little interesting kind of thing. You know, it's a different way of looking at these things. So that's that one. Now, the next part here is, I'm not exactly sure how I'm going to be able to do this with one hand, but I'm going to try. So here I've got these 2 pieces, but it's actually, it comes out of a triangle. Okay, that's your equilateral triangle. And when you divide the triangle into two equal halves, you take the triangle, and when you flip that and then reattach it, you get this kind of a parallelogram shape. Okay, so this shape here is derived from this. And when you put this like that, you get a rectangle. When you put this like that, you get that shape. And you can also get this shape if you take this and flip it that way and then reattach them that way. You get that kite shape right there. And if you take them and put them together like this. I really can't do this with one hand. Like that. Oh, that fell in the thing here. You get this shape. So, which is this one here. So all of these, 1, 2, 3, 4, 5, these 5 shapes I got from an equilateral triangle. So that's the basic kind of logic behind this, and this is why I'm going through these steps, so you'll understand what I've done later. And the same thing for a square. You know, if you divide a square on the diagonal, and then you attach this end here to the other end, you know, right where they share the same side there, you'll get that shape. And in the very way I showed you how the different arrangements of the triangle, you get that shape, and it also has a kite shape. And of course, if you split the square right down the middle, and then you stack the two halves on top of each other, you'll get an elongated rectangle, which I didn't bother because that's a pretty easy one to understand. So that's that. Okay, yeah, so the next is these. I was playing around with those shapes. These are 3 of the 5 of the different triangle shapes that I got from the triangle. Or it's 4 of them. There's that one, there's that one, and there's that one. And I came up with this, like a really cool pattern here. So, you know, I'm showing you how you can take all those 5 other shapes, you can play around with them, and see if you can come up with some interesting patterns and shapes. And if you take, you know, the sides here like this, where what you can do is you can actually close this, and it'll give you a perfect triangle. You know, if you wish to have this as like a kind of a fractal of sorts, you know, another triangle would fit in here. You put one more on top, and that'll give you the top of the triangle. And these two little halves in here, they fit right in here. And then the same thing here, two more triangles, and then, you know, you get that side. In the same way, you'd get the third side. And then you would get an equilateral triangle. I didn't bother drawing that out because I think it looks cool this way. But anyway, that's a kind of like a newish kind of a design. And like I said, you can play around with the 5 other shapes that you can get from an equilateral triangle. And there's another example of one where I thought this one looks really cool. Same thing. I'm just playing around with all the different shapes from an equilateral triangle, and when you connect them all in a certain way, it'll, you know, in the gaps, well, as a matter of fact, the hexagon is also derived from those 5 shapes. If you draw a line from here to there, you'll get those 2 halves. Which is this one, right? So I got that from the triangle. So there's 2 of these, and in the middle is a rectangle. And that's how you get your hexagon. Or you can just put all the other pieces here together, and then you'll have these little areas here, which it'll just make the hexagon for you as this one here in the middle did. You know, I just simply attached this to this to this to this to this to this to this all the way around, and that just automatically gives you the hexagon shape in the middle. And so this like most of this stuff, this can also be a fractal. But, you know, these are something a bit different than just like a regular, just like a regular honeycomb pattern, or just a regular a triangle pattern, or just a regular, you know, like a cube pattern, and so forth. You know, it's kind of artistic as well, right? You're playing around to find new, interesting looking creative patterns. So those are the 2 I did. I didn't spend too much time on those because a lot of them have been done and stuff like that. So, but anyways, I thought that was really cool. That was a nice pattern there, or a nice design. And the same thing for, you know, unfortunately this is falling into a little thing in there. Okay. So the same thing for the Pentagon. If you divide it in half, okay, and you play around with it and put them back together in different ways, what I found is that I found 1, 2, 3, 4, 5, 6, 7, 8, 9. I found 9 other shapes that came out of a pentagon just by you know, dividing it into 2 halves and then reattaching them in different configurations. So that's how you get those. And there's like the first one I did. I mean, yeah, it's nothing special. Perhaps this has kind of been done before, but I was just showing how you can start to play around with these, and I believe it's this one here. So it's that shape there, and when you attach 5 of them together, you'll get a decagon in the middle of your pentagon. Right, easy enough, that one. And there's this one. That also might look familiar. That's that one there. And that will give you a fractal. And a kind of I forget what I was going to say, but yeah, it's interesting. You know, if that might be an interesting kind of design or an interesting kind of pattern that you would want, you know, other than just the ordinary. In different applications, you know, maybe in the border of a picture frame or something like that. And instead of just using, you know, like a regular a brick wall kind of pattern, well, here's another one, and this one actually looks, you know, really cool. And it's derived from a pentagon. And this is another one. There's another kind of a cool design, which came out of, which one is it? Okay. So it's that one there and this one here. So I used those two. And, you know, I had to play around with it and to find something that would give me a consistency, you know, something which will just continue on as a type of a pattern or a design or a fractal, if you will. And so when you arrange them and you piece them together like this, you'll come up with this really cool looking pattern here. It almost looks like a kind of a weave, you know, which is really cool. And yeah, so that's that one there. And there's this one. And this one's really cool as well. So you've got this one, and what's the other one there? Yeah, and it's this one, and this one. So those three I played around with, and I found this. Another really cool pattern. And like I said, this could be an interesting design in for some kind of an application. And then I found this one, which is even cooler. I mean, that thing's just looking pretty wild looking. Let me see here. So there's that one. There's the, where is it here? That one. And that one. So it's those ones. And they all, like, it's kind of like a jigsaw puzzle. You get all these pieces and you play around with them until you find like a way that they can connect with each other to give you a consistent pattern, design, fractal, etc. Right? So anyways, this I thought was one of the coolest ones. I think it's one of my favorites here that I found anyway. So that's a new geometrical design. That's a new geometrical pattern. It's a new geometrical fractal. I personally haven't seen anybody kind of do these kinds of things. So that's the fives. The six, the hexagon, obviously I didn't do. Everyone's very familiar with that one. So these are all derived from a 7, from a septagon. I think that's what it's called. And when you have your septagon, same thing. You might be easier to, yeah, then this is fine here. I can explain it here. So this is half right here. That's half. And when you get your two halves, you flip the one side over, and then that gives you this shape. Actually, you know, I'm going to come back to that. I forgot to mention something. This is the problem when you try to wing stuff. Let me just go back to this one here. So what happened with the 3, right? Your equilateral triangle. When I rearranged them, some of them, you know, instead of a 3-sided shape, they gave me a 4-sided shape. Okay, so I converted the 3 into a 4. You know, like this one here, some of them remain 3, and depending on how you reconfigure them, it can give you a 4-sided shape. So the 3, it's possible to turn the 3 into a 4 this way, right? And you're staying true to its geometrical properties. And same thing for the 4. You can reconfigure it so that the 4 can be converted into a 3-sided shape. You know, so the 3 it can be reconfigured into a 4, and the 4 can be reconfigured into a 3-sided shape. So that's just something interesting to keep in mind, because that's what that's what happened with the 5. When I reconfigured the 5, it actually turned into a 6-sided shape. 1, 2, 3, 4, 5, 6. Same with this one. This bow tie looking one. 1, 2, 3, 4, 5, 6. Same with these ones. 1, 2, 3, 4, 5, 6. So the 5 it can be reconfigured into a 6-sided shape. So there's something interesting here, and there's some consistency to this as well. Where now the 7, you know, this was originally a 7, made into 2 halves, and I flipped one side, and now all of a sudden it gives me an 8-sided shape. And these are different ones that I found, different configurations that I found within the Decepticon. 1, 2, 3, 4, 5. So I found 5 others. And actually, no, I found more. I found these as well. 5, 6, 7. There's more, but I'll get to that. But these are 7 basic ones that I found. And this, of course, was this one here, which I actually is not on this list here. So this is actually one of them too. Okay, so actually there's 8. There's 8 that I found to start. There's 8 other shapes that I found to start from reconfiguring a Hexagon. And so that's one of the patterns there. If you attach them a certain way, you'll get that. And once again, that'll be a fractal of sorts. You can just continue that on forever. So that's really cool. And this came from a Hexagon, right? And that's and that was another way I found of configuring that shape, and that gave me that pattern, which also came from the Hexagon. And of course, this will also be a fractal of sorts. Okay, so now comes, you can see here, where this one is different than this. That's hard to see, but I think you can see it there. Well, no, sorry. This is another one of that very same shape.